Hi everybody, welcome back. We are going to start our Unit 7, which is on systems of equations and inequalities. And we're actually going to start with systems of equations, even though we just did inequalities. Little preview is that systems of equations is basically just two equations that have one solution in common. So they have 1 point in common. Okay? So that's it for systems of equations. So we're going to go ahead and talk about that now. Let's go. Alright, so first we have vocab. First vocab is a system of linear equations. Is a group of two or more linear equations with the same solution. I know, deja vu, right? So that's all it is, which is really nice. Here's the next thing, a solution. Ooh, how about we minimize that? Yeah, I don't know why this won't go away. Weird. Okay, here we go. A solution to the system of linear equations is an ordered pair, or pairs, possible to have more than one, yes, that makes all the equations in the system true. So this is one ordered pair that would work for every single equation. On a graph, it is the ordered pair that all the equations share. So the intersection or the overlap of the lines. Okay? And remember, if you need more time, just go ahead and pause the video right now. Okay. And then, when you're done, go ahead and unpause it right now. Okay. So, there are kinds of systems. There's three kinds of systems. Two categories that you can have. You can have consistent systems, which are systems of equations that have at least one solution. Okay? You're going to have a solution for it. There are two kinds. There's independent consistent systems, which have exactly one solution. This is probably one you're going to see most often. And then there's dependent consistent systems, which are the systems that have infinitely many solutions. Okay? And then there's those inconsistent systems that actually don't have any solutions. Okay? Remember, if you have any questions on this, please write them down on the side of your notes, and I will answer them next class, okay? Alright, so here are what they actually look like. So, consistent independent systems, this is what they look like graphically, okay? Where they actually intersect, and this point right here where they're crossing, which isn't actually like a nice clean point, but that's okay. This is the solution right here, at that ordered pair. Okay? Because it's what they both have in common. They're both on top of that. They're both using that ordered pair. So that's our solution. Or consistent dependent actually have infinite solutions because they're two lines on top of each other. So algebraically that would be like two equivalent equations. Okay? They might be in different forms, but when you change them to the same form, you end up getting the same line. So this is infinite number of solutions because the overlap of all of them creates, like, all of these ordered pairs work for both lines because they're the same. So all of those points on the lines are solutions. Okay? And then we have inconsistent, and this is what it looks like. So these are two parallel lines, even though they don't look super parallel. They're parallel. Two parallel lines, they never intersect, so that means they don't share any common ordered pairs. Okay? So that means there's no solutions. So you will need to know these names and what they look like graphically, okay? As well as what it means algebraically when you get like one solution, infinite solutions, and no solution, okay? Alright, there are three ways to solve a system of equations. There's graphing, substitution, and elimination, which is sometimes called linear combination. Okay? Today we're going to be focusing on graphing. Next class we'll be doing substitution, and the following class we'll be doing elimination, and in the last class we'll be doing inequalities. Okay? But today we're just focusing on graphing, which is really nice. Alright. Solving systems by graphing. Sorry, it's like wordy, but it's not really a lot of words. It's just, I couldn't figure out a better way. Okay? So, there's 4 steps. Step 1 is change all the equations in your system to slope-intercept form. So y equals mx plus b. Okay? Then you're going to go ahead and graph all the equations on the same coordinate planes. It might be helpful to use different colors for this, okay? So if you have colored pencils or markers at home, please feel free to use them. I will have them in class, and I'll have them out for your assessments as well, including the days that we actually do graphing in class, okay, for like activities. 3, find any points that all the equations have in common. So the intersections or the overlap they have. Those ordered pairs are the solutions to your system. Okay? And then step 4 is just to check your solutions. So you plug them back into the original equations from your problem and see if you get a true statement. So you want to try it for each equation. Okay? Those are the 4 steps though. If you missed any of it, please rewind the video and pause it so you can get all this down. It is important. Alright, so let's try an example. So we have to find the solutions for the following system, which is this. 3x minus y equals 6 and y equals negative 2x plus 4. Alright, so our first thing is to change this into y, or slope-intercept form. So that would, that's soft. Well, poo. That's not what I wanted to show you. Avert your eyes. Okay, well, to change this into y by itself, I would be getting y, or negative y equals, I'd subtract the 3x from both sides. This 3x from both sides, so that would mean I'd have negative 3x here, plus 6. And then the next thing I do is divide everything by negative 1, or multiply everything by negative 1, getting me y equals 3x minus 6. Okay? And, yeah, that's on there. Okay. So, that's my graph. That's the first one I'm going to graph. And I'm just going to pick this. Why does it never work when I want it to? This is so sad. Guys, you need to feel sorry for me right now. Okay? Because you should. This is really sad. It doesn't like me at all. It's so sad. Oh my gosh. Well, there. That showed up. That one shows up. Why does this one not want to show up? Ugh. Alright, well, let me go ahead and draw the line myself because it doesn't want to work. So here's negative 6. Gotta go up. Oh, no, I can't do that. Sorry, guys. This video became much longer than it needs to be. Okay. It'll still be short. Okay, so I gotta graph this. So I got, starting at negative 6, I'm gonna go up 3 and over 1. Up 3 over 1. There we go, I figured it out. Hey. There, and the other side is just not the right color. Down 3 and over 1 right here. It's not super straight, but it'll work. And then I'm going to change the color so it's not black. That doesn't help me. Let's make it red. Okay. There we go, I graphed it. See? I graphed it. I'm impressed with myself. And you should be too. Ooh. That's not helpful. So, avert your eyes again, please. So now I have y equals negative 2x plus 4. And I'm going to go ahead and graph that one. Hey, look, that one shows up without a problem. So that's there, because I'm starting at y, the y-intercept, and I go down 2 over 1, down 2 over 1. Now, if you look right here, look, it's where they're intersecting. Look at that. So that is actually my solution. Ta-da! So that's why the green thing popped up before. Solution, 2, 0. Now we're going to go ahead and check it by plugging it back into the equations. Oh, I can make this big again. Y'all love me so much. I know you do. So we got 2 going in for x. We got 0 going in for y. So that matches the first equation as it was given, not when I changed it. Equals 6, so I go ahead and do it. I get 6 minus 0 equals 6. 6 equals 6 comes out to be true. Now the second one, y equals negative 2x plus 4. Plug it in 2 for the x, plug it in 0 for the y. Simplifying. Negative 4 plus 4 gives me 0. 0 equals 0 is a true statement, so that is, in fact, the solution. Yay! Okay. Enough of me. Now it's your turn. Try this on your own. You got 2 equations, and I was mean because I give you one that was already in slope-intercept form. I know. I'm horrible. So you have to get both of these in slope-intercept form and then graph them on the graph. And, well, you should find a solution then. Okay? So go ahead and pause the video. When you come back, I will have your answer. Okay? Good luck. Okay. So, we have the graph. Let's see if these will work. Hey, look! That one showed up. That one. And, oh, where'd the other one go? Where'd it go? It's over here. There we go. Look at that. 2 lines. Now, let's make sure I know which one's which. So, this one, this top one, ended up being this guy, the blue one. The top is blue, bottom is purple. Yeah, that makes sense. Okay, so our solution is actually right here, and I wrote it down way down here for some reason. So the solution would be 4, -4. And you check it, plug it back in, comes out to be true both times. Okay? Alright, now, look at my face. Example 2, write, oh, I wasn't sure that. Oh, just kidding. Nothing happened. Alright, write the system and the solution from the graph. So this one, they give us 2 lines. We just have to write the equation for each line, and then we have to write the solution. So, whichever one you want to do first is up to you, but I go with the lines first. So here, I have a y-intercept of 1, 2, 3, 4, 5, and a slope of 1, 2, 1, 2, 3, 4, 5, 6. So 1/3? Yeah, and it's going down. So -2 over +6. So I get that. And here I have a y-intercept of 1, 2, 3, 4, and a slope of 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 4 over 6. So that reduces to 2/3. Bada bing, bada boom. That's my system. And my solution is actually right here, which is at 9, 2. There you go. That's it. So this last one, you're going to do on your own, and you're going to tell me what the system is and what the solution is. So, on your mark, get set, go! Good job! You did amazing. Alright, so let's go ahead and check our answer. So the first one, for the green one, we got y equals -2x plus 5, because y-intercept is 5, the slope is down, going down 2 and over 1 each time. Second one, we got a slope of 3/4 and a y-intercept of -7, so that means you're going up 3 and over 4 each time. And your solution is right here where they're crossing. Oh, and my solution is somewhere here. 4, -4, again. Okay? And both of these that we did, these last, actually all 4 of them, I think. 1, 2, this one was, and that one, yeah. All 4 of them were consistent, independent systems. Okay? So if you have any questions, please write them down. We will go over them next class, and we will have a ball. Okay? I will see you in class. Have a great day. Don't forget to study hard. Alright? I'm not going to say bye yet, because I haven't gotten to the recording thing. So now I can say bye. Goodbye.